In this video, we're going to derive what is called the point-slope equation for a line. First, I want to talk about the slope formula. We've already discussed slope. Slope of the line is computed by taking any 2 points on the line and computing the ratio of the change in y to the change in x as you move from one point to another. And you likely remember that this symbol triangle here, this is read delta y, this is read delta x. This is a shorthand that is commonly used for the change in a variable. So the slope is the change in y, or delta y, over the change in x as you move from one point to another on the line. So for example, if I'm going to move from this point on the left to the point on the right, the change in y, delta y, is plus 4 because we're moving up by 4. The change in x is 8, plus 8 because x is increasing by 8. And the ratio of those is the slope. Plus 4 over plus 8. Notice the change in y is always on the top, change in x is always on the bottom. And this reduces to 1/2. I'm writing the pluses to emphasize that this is an increase, y is increasing, and this is an increase, x is increasing. You of course wouldn't need to write those pluses. Oh, and the letter m is typically used to represent slope. If we move the other way between these 2 points, the slope is the same. The slope only depends on the line. Why is that? Well, if I move from here to here, x decreases by 8, so delta x is negative 8. Y decreases by 4, we move down 4, so delta y is negative 4. So again, if we still divide delta y by delta x, we get negative 4 over negative 8, which is still 1/2. The slope calculation also doesn't depend upon which 2 points we pick. If I choose these 2 points instead, I'm still going to get slope 1/2. Change in y is plus 2, change in x is plus 4, and the ratio is still 1/2. Plus 2 divided by plus 4, delta y over delta x is still 1/2. So, to summarize, to compute the slope of a line, we choose 2 points and compute the ratio delta y over delta x as we move from one point to another. And we get the same answer no matter which 2 points we choose on the line. So this is one way of writing the slope formula, change in y over change in x. Another very common way of writing the slope formula is if we have coordinates for these 2 points. If this is x1, y1, and this is x2, y2, then we can compute these changes by subtracting coordinates. For example, here the x-coordinate is 3, and here the x-coordinate is negative 5. And if we do 3 minus negative 5, we get the change of plus 8. Likewise with the y-coordinates, if we do negative 6 minus 6, we get the change of negative 12 because we're moving down 12. So we can compute these changes, delta y and delta x, by subtracting coordinates. So this is another very common way of writing the slope formula. Instead of writing delta y, we write a difference in coordinates. Instead of writing delta x, we write a difference in coordinates. Notice in this formula, this always has to be 1 point, and this is the other point. You have to go in the same order, top and bottom. This is like point 2 going first. This is point 1 going second. Now, let's derive the point-slope equation of a line from the slope formula. Suppose we have a line where we know the slope and we know one of the points on the line. I'm going to be specific at first because it's easier to understand specifics. Here's a line with slope negative 2/3, and that passes through the point 1, 3. There's the point 1, 3, and this line's slope is negative 2/3. It goes down 2 and to the right 3 as you move from point to point on the line. We can use this to write an equation of the line. We're going to come up with an equation where every point on the line satisfies the equation, and every point that's not on the line doesn't satisfy the equation. Points on the line make the equation true, points not on the line make the equation false. Suppose xy is another point on this line. Say right there. It could be anywhere on the line. Since xy and 1, 3 are on the line, we know we can get the slope between them, and it's going to be negative 2/3. So using our slope formula, since we know the slope is negative 2/3, we can write our slope formula, m is y2 minus y1 over x2 minus x1, as negative 2/3, because that's the slope, and then I can put in y minus 3 on the top, that's the change in y, and x minus 1 on the bottom, that's the change in x. This is what we can write between these 2 points on this line. There's the changes. Change in y is y minus 3, the change in x is x minus 1. If I multiply this x minus 1 out of the denominator, I get y minus 3 equals negative 2/3 times the quantity x minus 1. And this is an equation for this line. Now what does that mean to say this is an equation for this line? What it means is if I have a point on the line, and I plug it in, I know it will make the equation true. For example, it appears that negative 5, 7 is on this line. There it is right there. If I plug x equals negative 5 and y equals 7 into that equation, let's see what we get. There's the equation again. Now I'm going to put in x equals negative 5 and y equals 7. So there we go. Doing some simplification, the left side is 4. Inside the parentheses I get negative 6. And 2/3 of 6 is 4. So this is a true statement. Since this point was on the line, we plugged it into the equation and it was a true statement. Likewise, if we take some point not on the line, like 6, 5 way over here, and we plug those in, 6 for x and 5 for y, we'll get a false statement. This is certainly not true. This side's positive, this side is negative for once. So what is the general form for the point-slope equation of a line? Well, what we're going to do is we're just going to generalize what we did before. Before, we had a specific point, 1, 3, and a specific slope of negative 2/3. So I'm going to replace this specific point with the general point, x0, y0. So this is going to represent some point we know is on the line, like 1, 3 before. And I'm going to replace negative 2/3 with the variable m, which we usually use for slope. So that changes our equation. Here's the equation we had for the line before into this. I've replaced negative 2/3 with the slope m, and I've replaced 1 and 3 with these variables that represent some point that we know to be on the line. So in this form here, this is point-slope form for a line. M represents the slope of the line, as it usually does. x0, y0 represents some point that we know to be on the line. And x, y remain as variables in this equation, as they did up here. And in the example videos, we'll show you how to put this to work, and also some of the things you have to be careful about when you use it.